Hi friends, in this video we are going to discuss about how to calculate the magnitude and phase angle for any AC quantity. For example, we know that in AC circuits we have the voltages, we have the currents, we have the impedances. Like that there are so many quantities are there. So whenever we are going for the analysis of any AC circuit, always we need to use the all the quantities in polar form. Okay, so without using the polar form concept or polar form quantities, it is not possible to analyze any AC circuit. Okay, so that is the reason why, so whatever the quantity is there, for example voltage or current or impedance or some other parameters or some other quantity, so always we need to convert into polar form from rectangle or complex form. Okay, so from complex or rectangle form into polar form if you want to convert, so always it is possible by calculating the value of magnitude and phase angle for the given quantity. Okay, now see here, for example, we have in this video we are taking one impedance. Okay, so that impedance, actually the expression of impedance is equal to z is equal to r plus j into xl minus xc, and the unit of this particular impedance is always what? Ohms. Now we know that, so here in this particular video we are taking the value of resistor is equal to 10 ohms, XL is equal to 30 ohms, and in the previous video we discussed about the conversion of XL and XC from inductance and capacitance. So how to convert the capacitance into capacitive reactance and how to convert the inductance into inductive reactance. So I already explained in the previous video, and that particular video link is available in this particular video description. So here XL represents the inductive reactance, XC represents the capacitive reactance, and we have the value of resistor and inductive reactance, capacitive reactance values. Now here coming to the impedance, that is Z is equal to R plus J into XL minus XC, and the unit of this impedance is ohms. Now substitute the value of the resistance. Resistance is 10 plus J into value of XL is 30 minus the value of XC is 20. Now here if I am going to simplify, so Z is equal to 10 plus J into 30 minus 20 means you will get the value of, so this particular XL minus XC is 10. Okay, now here the value of XL minus XC is 10. Now this impedance Z is equal to 10 plus J into 10 is the value of impedance after substituting the values. Now what we are doing, we are going to get the magnitude and phase angle for this particular impedance expression. Okay, now see here, first thing is calculation of magnitude. So whenever we are going for the calculation of magnitude for any quantity, so here the magnitude of impedance, so here the formula is given by, whenever we are going for the calculation of magnitude for any quantity, always we need to use this formula. So that is mod Z is equal to, so under root real value square plus imaginary value square. Okay, so under root real value square plus imaginary value square. So now this formula is always used to find the magnitude for any quantity. Okay, now see here, now what we are doing, now first we need to find the magnitude for this particular expression. Okay, now what is the actual expression? So that is Z is equal to 10 plus J into 10 ohms. Now this is the actual expression. Now what we are doing, now we are going to find the first magnitude for this particular expression. Now so magnitude of impedance, that is equal to, so mod Z or magnitude of Z is equal to under root, so real value or real square or real value square plus imaginary value or imaginary value square. Now see here, so mod Z is equal to, real value is always the value of resistance. Okay, here the real value means the value of resistance represents the real value, and J into some value, it means in this value of impedance J into 10, here 10 is the value of what? XL minus XC. Here the XL minus XC is representing the imaginary value. Okay, so here J into 10 means the value of imaginary is always 10 in this particular impedance expression. Now see here, so real square means what? 10 square, that is the value of resistance. Now here imaginary square, again the value of imaginary is 10 square. Now that is equal to, so mod Z is equal to, so here 10 square means 100 plus 10 square means 100. Now mod z is equal to, so under root 200. Now what is the value of root 200? The value of root 200 is always how much? So here we can also write this particular, so this particular under root 200, it will get the value of 14.1421 ohms. Now this is the value of what? The given, for the given expression, we got the magnitude value as mod z is equal to 14.1421 is the value. Okay, now unit of this particular magnitude is always ohms only. Now coming to the phase angle. What is the phase angle? How to find the phase angle for this particular impedance expression? Now phase angle always represented with the theta. So phase angle theta is equal to, the formula is always tan inverse of imaginary value or imaginary term divided by the real value or real term. Okay, now here theta is equal to, so theta is equal to tan inverse of imaginary value means what? From this particular expression, imaginary is the XL minus XC resultant, that is what? How much? 10 divided by the real value is what? The value of resistance, that is 10. So that is equal to, here theta is equal to tan inverse of 10 gets cancelled, then you will get the value of tan inverse as, so tan inverse of 1. Now here what we are going to do, if you want to get the value of this particular tan inverse, what is the value of this particular tan inverse? Here the tan inverse of 1 is always given by the value of 0.78. Here theta is equal to 0.7853 degrees. So this is the phase angle for this particular expression. Okay, now see here, this is the phase angle for the given expression and this is the magnitude of an expression. Now after getting the magnitude and phase angle, now we are going to get the polar form of a given impedance. Now what we are doing, we are converting from complex or rectangle form into polar form, because this polar form, the value of impedance or voltage or current, any value is always in the polar form. If all the values in the polar form, then only it is possible to analyze any circuit. So that is the reason why the polar form of a impedance, so polar form of impedance, that is Z, is given by, so Z is equal to magnitude, so magnitude having some phase angle. So having some phase angle. Now see here, now you know the value of this magnitude and also you know the value of this particular phase angle, because just now we calculated. Now Z is equal to, the magnitude value is 14.1421 is a magnitude and having an angle of 0.7853 degrees. Now see here, so Z is equal to 14.1421 having an angle of 0.7853 degrees. Now this particular impedance represent the polar form of a impedance. Okay, so polar form of impedance Z. Now this particular value is required in any AC circuit to find the value of currents, and also so this particular value is directly we are converted from the value of what? The complex form of impedance into this polar form. Okay, so this is the procedure we need to follow whenever we are going for the converting from complex or rectangle form into polar form, and in AC circuit the polar form is mandatory to analyze any circuit. Okay, thank you so much for watching and please do subscribe my channel. Thank you.